Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night.
I'm your host, Wayne Zuhl, and this is the Astro Guy podcast. Last month, we saw Mercury put on a nice show, joining Venus, Saturn, Jupiter, and the Moon for a few evenings before Mercury got lost in the twilight glow. Mercury makes a brief appearance in the morning skies in February. More on that in a bit. Additionally, by the time this is released, the James Webb Telescope should be in orbit around L2 and will continue cooling and calibrating its instruments. We expect the first real images from JWST sometime in May or June at the earliest. As February begins, you can still catch bright Jupiter low in the west about 45 minutes after sunset. By mid-month, Jupiter will be lost in the twilight glow, and will be lost in the evening and then morning twilight until mid-April, when it will emerge in the morning skies. Neptune will be low in the west, lingering on the border of Aquarius and Pisces, and sets about 8 p.m. at the start of the month, and by month's end it will be lost in the evening twilight glow. To spot Neptune's bluish disk, you'll need a telescope at moderate magnifications. With at least an 8-inch telescope early in the month, you might be able to spot 13.6 magnitude Triton, Neptune's largest and brightest moon. Uranus will be visible in the evening sky during February. At the beginning of the month, it is in Aries, glowing at magnitude 5.77. You should be able to spot it easily in binoculars, where it will look like a pale bluish-green star. In a telescope, you'll be able to make out the disk of the planet. It only spans 3.6 arc seconds, so you'll need to boost the magnification to make out the planet's disk. Uranus is very well placed for observing this month, and it will be high in the southwestern sky at nightfall. At the start of the month, it sets at 12:41 a.m., and by month's end, it sets around 10:40 p.m. If you want to challenge your observing skills using at least an 8-inch telescope, try to spot the 4 brightest of Uranus's moons: Titania, Ariel, Umbriel, and Miranda. Titania glows faintly at magnitude 14 and is the brightest of the 4. With practice, patience, and under a dark sky, you should be able to pick out at least Titania. Miranda is the faintest of this group, dimly glowing at magnitude 16.58, so this is a tough challenge and may require very dark skies and a larger aperture to try to pull it out. If you don't have access to a large telescope or dark skies, the early morning hours will provide lovely views of several bright naked eye planets. On February 1st, Venus is 11 degrees above the east-southeast horizon. Venus will be bright, shining at magnitude minus 4.51. Through a telescope, you'll be able to resolve a 16% illuminated crescent Venus that spans about 48.6 arc seconds. By the end of the month, Venus will be about 15 degrees above the horizon as twilight begins, and will be about the same magnitude, but will display a crescent about 38.5% illuminated, and will have shrunk to just over 31 arc seconds in diameter. If you're going out to look for Venus, you'll be able to spot Mars, which will appear to get nearer to Venus each day of this month. At the beginning of the month, the 2 planets are about 9 degrees apart from each other in the morning sky. By the end of the month, that separation is down to about 5 degrees. Venus will appear to the left and above Mars all month, seeming to climb closer and higher as the month goes on. Mars is relatively easy to spot. It's shining at magnitude 1.4, much fainter than Venus, but its disk is small at only 4.3 arcseconds. Mars will be putting on a much better show later in the year when it reaches opposition, or the point in its orbit where the Earth is directly between Mars and the Sun. At opposition, which occurs on December 8th, 2022, Mars will rise when the Sun sets and set when the Sun rises. By autumn, Mars will be putting on a much better show through a telescope. But for now, it provides a pretty naked eye sight as it dances with Venus in the morning sky. Later in the month, on the morning of the 27th, with the aid of binoculars, try to spot Mars and the 14% crescent moon about 4 degrees below Mars. Mercury is very low in the morning sky, and around the middle of the month is the best time to try to spot it, but it will be very low on the eastern horizon. February begins the month with the moon being new, so it won't be visible in the sky for a day or two. It will appear back by about the evening of the 3rd, when you'll see its crescent in the west after sunset. Full moon occurs on the 16th this month. The best days to observe the moon will be from the 4th until around Valentine's Day. Observing the moon through a telescope during these evenings will show shadows that help reveal the height and depth of many lunar features. Observing the moon when it's full reveals a moon devoid of shadows. It is very bright with little contrast, so less details tend to be visible. Either way, the moon is an absolute joy to observe in any telescope. We'd love it if you'd share some of your recent lunar images or sketches with us. Do you have a favorite lunar feature? If so, let us know what it is. There are no meteor showers of note to view this month. Moving beyond the solar system, we're going to take a look at 2 of the finest winter constellations in our skies. As darkness falls, you'll find Gemini high in the southeastern sky above and to the left of Orion. The twins of Gemini are the stars Castor and Pollux, which make up the heads of the mythological twins that the constellation is named for. Orange-hued Pollux is the brighter of the 2 stars, shining at magnitude 1.29. Pollux is an interesting star for several reasons. It is an older, giant star lying about 34 light-years away. Pollux is about 2 times the diameter of our Sun and is 9 times more massive. It is the closest giant star to us. Pollux has a planet revolving around it that was discovered in 2006. The planet, named Sirius, is calculated to be a gas giant, at least 2 times the mass of Jupiter, and it orbits Pollux at a distance of 1.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 93 million miles. Castor, on the other hand, is a very different star system. Made up of 6 stars, Castor shines at magnitude 1.58 and appears whitish in color. Its 2 largest stars are both white A stars. The system is made up of 3 pairs of binary stars. The 2 white A stars each have red dwarf companions, and the 3rd pair of stars are both red M-type dwarf stars. Now you might be asking yourself, what's an A or an M star? What are these letters? This brings us to 1910, when 2 astronomers, Ejnar Hertzsprung and Henry Norris Russell, came up with a diagram that astronomers refer to as the Hertzsprung-Russell, or HR diagram, that is a scatter plot of stars according to their spectral type and luminosity. Astronomers have been classifying stars using the MK or Morgan-Kennan system, which classifies stars by temperature. There are letters assigned to each temperature range. The hottest stars are class O stars, while the coolest stars are class M. There are several different ranges labeled O, B, A, F, G, K, and M. I remember this with the mnemonic, "Oh, be a fine girl, kiss me." Each letter is divided into 10 numbers, breaking down the temperature scale even more. There is also a designation for luminosity as well, using Roman numerals. For instance, our Sun is classified as a G2V star. There are two other spectral classes that have been added to the HR diagram: D, which is used for white dwarf stars, and C for carbon stars. In a later episode, we'll talk about the HR diagram and different types of stars. Getting back to Gemini, it holds about a dozen deep sky objects that are within easy reach of a 6-inch telescope from dark skies. The brightest and easiest deep sky object to spot in Gemini is the Open Cluster M35. M35 has an interesting bonus as well. You can find M35 by hopping from the star Tehat near the Castor twins' foot, then hopping to Propus, and then 1 Geminorum. From there, sweep about 4/5 of the way to 5 Geminorum, and you'll be looking right at M35. Located about 2,770 light-years away and measuring about 28 arc-minutes in size, M35 appears almost as large as the full moon and is made up of just over 300 stars, glowing at magnitude 5.1. In binoculars, the cluster looks like a mottled patch of light in the sky. In a telescope, you should be able to resolve half a dozen 8th magnitude stars, as well as several fainter ones. This is one of my very favorite open clusters to observe. Located about a quarter of a degree southwest of M35 is the 8.6 magnitude open cluster Ngc 2158. This cluster is about the same size as M35, but is about 9,000 light-years further away, so it appears smaller, spanning only 8.5 arc-minutes. In a telescope that's 4 inches or larger in diameter, this is a stunning pair of objects to observe. Gemini has several other open clusters to explore, but a fun object within its boundaries is the planetary nebula Ngc 2392, which is commonly known as the Eskimo or the Lion Nebula. To me, in images obtained by the Hubble Space Telescope, this nebula actually looks like a lion. This is the remnant of a star that went nova. We're seeing the outer layers of gas were puffed out by the star about 10,000 years ago. Appearing relatively large for a planetary nebula, this object is about 33 arcseconds in diameter. The nebula glows at magnitude 9.6 and should be easy to spot in a 6-inch or larger telescope. In a telescope, it will look relatively spherical, with the inner halo appearing brighter than the outer halo. Higher magnification will reveal more details, but will make the object appear dimmer. Using averted vision, where you focus your eye on the edge of the field with the nebula in the center, may help you to see subtle details within the nebula. To locate Ngc 2392, start at Pollux and sweep to Delta Geminorum, or Wasat, and then move about 2 degrees east and 1 degree south to find the nebula. As the night goes on, Canis Major comes out to play. From 40 degrees north latitude on February 1st, around 11 p.m., you'll spot Sirius, the dog star, shining brightly about 32 degrees high. By the end of the month, Sirius will be at its highest in the south around 8 p.m. Sirius is the brightest star in the night sky. Its name comes from the Latin for scorching. Sirius is about 2 times the mass of our Sun, yet it is 25 times more luminous. Currently, Sirius is about 8.6 light years away, making it the 5th closest star to us. It is so bright only because it's so close to us. Over the next 60,000 years, Sirius will move even closer to our stellar neighborhood and will brighten quite a bit. However, in 210,000 years, it will have moved far enough away to no longer be the brightest star in our night sky, with that honor falling to the southern star Canopus. Sirius is also a binary star. In 1844, Frederick Wilhelm Bessel calculated that it had an unseen companion. Its companion star, Sirius B, known as the Pup, was first observed visually by Alvin Clark in 1862 while testing out an 18.5-inch telescope that he had made. The Pup is around 10,000 times fainter than Sirius, so observing it visually is extremely difficult due to the bright glare from Sirius. A fun thing to do with Sirius is to find it in a low-power eyepiece, then defocus the star a bit. With most stars, this helps to show their colors, but with Sirius, because it's so bright and is a white star, it can reveal many different colors flickering. This is due primarily to atmospheric conditions on Earth. Canis Major offers us more than just Sirius to enjoy. As far as constellations go, to me, this one looks a lot like a dachshund, despite Canis Major meaning the greater dog. There is a constellation Canis Minor, which we'll talk about in a future episode. About 4 degrees due south of Sirius is the Open Cluster M41. This cluster spans about 38 arc minutes and glows at magnitude 4.5, making it an easy thing to spot in binoculars as a diffuse patch of light a little larger than the full moon. In a telescope, you can resolve several of the cluster's 100-member stars. This looks best at medium powers, and you can make out several red stars in the cluster. M41 lies about 2,300 light-years away from us. Canis Major offers another bright open cluster for us to enjoy. NGC 2362 shines even brighter than M41. Start at the star Wesen and move 2.5 degrees east and 1.5 degrees north, and you'll be looking at Tau Canis Majoris, which is actually the brightest star in the cluster. NGC 2362 shines with a total magnitude of 3.8 and is made up of between 100 and 150 stars. This cluster appears about 6 minutes in diameter and should look good in any telescope. This is a young star cluster having formed between 4 and 5 million years ago. There is a nearby nebula seen in photographs known as Sharpless 2-10 that is associated with the cluster. Both the nebula and the cluster are about 4,800 light-years away. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.